to share the next one. We're going to hear from Carlos for handling errors in Ruby using functional programming. So Carlos, take it away whenever you are ready, please.
Oh. Can you guys see my screen?
Yes.
Okay, cool. Hi, everyone. Today I will be talking a bit about functional programming in Ruby. Probably a lot of you have already heard about functional programming. And this is probably one of the first things that you can bring from functional programming to Ruby. Me, I am currently working as senior developer in REA Group, realestate.com.au. We are always hiring for Ruby and Scala developers of mix of Ruby and Scala. So if you are interested, feel free to reach out to me afterwards. And this is currently how it's working for my team. My team is full of experienced Ruby developers, but lately we have been working in some Scala projects, some new Scala projects. And I thought we could start taking some learnings from Scala and take it back to Ruby. So today we are talking about how to deal with errors, specifically about how to deal with optional data. So what's optional data? Well, optional data is just data that can be there, but sometimes it's just not there. Maybe you had a customer with an address. Usually you have your address, Chapel Street, or Yara, whatever, but sometimes it's missing there. For some reason, it's not in the database, for example. So we will have a look at how to deal with these cases. So there is a snippet of code here. There is a few classes here, foo and bar. They should be easy to read. They both only have a constructor, and they are just accepting one thing in there in the constructor. So if you have a look at foo is accepting a bar in the initializer, and then we will make that accessible later with the attribute reader. Just let me use the annotations from here, if I can find it. I cannot see the annotations well, maybe without annotations. In the other class, bar is receiving a bus variable in the constructor. It could be a string, for example. And then with the attribute reader, you can return that value of bus. Can you guys just confirm if you can see my cursor?
Yep.
Okay, cool. Awesome. So if you are struggling a bit thinking about these classes, if it's too abstract, you could think about foo as being, for example, customer and bar being address. So what we are going to do is we are going to associate here, we are going to associate a customer foo with one address, bar. I just like to have it a bit more abstract and saying that we are going to have an instance of foo that will be associated with an instance of bar. So now we're going to create instances of this, and we're going to do the association. So the code will look a bit like this. So if you go from the inner part of the first line, you're creating a bar.new bus. You're passing that string there, and then that instance that is built, you're passing it to the constructor of the foo class, and we are going to call foo to that object. And then we're going to try to call those attribute readers that we defined before, foo.bar.bus, and we are going to append that to the string hola. And even it looks like an operator, the plus there is just a method in Ruby. So basically we are calling 3 methods there. So this is how it should work. This is a correct initialization of these objects. And when we call this, we are going to get this result, bus hola. And so that's cool, but this is the ideal case. That's not what is going to happen always. We are going to have cases where the objects haven't been initialized correctly. There is missing data. The data was not in the database. For some reason, it's not there. And then the problems start. So for example, let's say in this case, instead of having as before that we are passing the bus string, let's say we are passing nil there. And the first line is, the rest is the same. Now, because that object is not initialized correctly, what's going to happen is when we call the same chain of methods, this is going to explode. This is going to explode. This is going to raise a no method error. It's pointing to the plus there. So that means that the result from doing foobar.bus was nil, and then nil doesn't have the plus method in there. And this is not a nice result for us. Having an exception like this is not that useful. Imagine you get your user a message with this error in a website, for example, then they're not going to be happy. Here there is another example. We can have the object that we had before called bar. We can do the whole bar object nil, and this will also explode and throw an error. It looks very similar. It's still raising a no method error, but it's in a different place because now foo.bar is nil. So it's saying it cannot call bus on a nil there. This problem is very common. I think it's famous because usually you can find it in production because it's very difficult to cover all the cases for null or nil values exhaustively. But yeah, the people it's working with this all the time, and there is some ways to handle this. We'll see this now. Here I'm just repeating the same instructions as before. We are initializing an object that is not correctly initialized, and then it explodes as before, same. Now we're going to see what's the basic way to handle this. The basic way will be trying to avoid to raise exceptions. So you just need to check for nils. It will be a bit like this. And people call it this pyramid of doom. Actually, I never have heard anyone saying that term, but you can see in Wikipedia and in some books sometimes. But yeah, you can see the pyramid form there. Yeah, that's cool. With that, you are not gonna raise exceptions anymore because you are checking at every step that you have something sensible, and that that your objects are the state is consistent. And then when you call the same chain of calls as before, foo.bar.bus.plus hola, if there is something that is not initialized correctly, you will return nil instead of exploding with an exception as before. Some people doesn't like this being that nested to the right, so you could do something like this instead. Looks a bit better. Is basically the same. But the problem with these solutions is that it's hiding the intention of what you want to do. You just wanted to do this. You just wanted to do foo.bar.bus plus all and not exploding, and you ended up with all this code. And this is just when you have 3 check-ins there, but it could be more than that. The chain could be longer. So it's just kind of polluting your code and making it more difficult to understand. But it works. It works, and it's okay. And there is more solutions to this. We'll see it. So here we have the same case again. If we are initializing the first variable, in this case as nil, and then calling that chain of methods will explode. A basic way to solve this that most of languages probably can do is relying on a feature of the AND operator. The AND operator has this short circuit property. That means that when you are evaluating both operands there, if the one in the left is false or nil or false in Ruby, it will stop and will not execute the second operand. So you can take advantage of this property and build something like this. So we have the expression that we really want is the last one, and it only will be executed if all these three checkings in the left are correct first. That's a nice way to deal with that. The people from Rails created this long time ago. They monkey patched the object class that every object is inheriting from, and you can do something like this that I think make a lot of sense. It's saying when you have a foo, try to call a bar operation. If you can, return the value, otherwise return a nil. And this happens again for try.bus, it happens again. So what it means is it's gonna try every time and it's never gonna explode. If it cannot do it, it's gonna return nil. There is a newer version of this that was implemented on the Ruby language itself. Instead of this that is Rails, it's on the active support gem. So it looks like this. Same idea. You call foo.bar.bus, and if it anywhere is nil, it will return nil the whole chain. Yeah, I think that's cool. That looks really good. The question is there any other alternative? I think all these solutions are quite common. But is there any alternative for this? So yeah, today we're going to talk about one alternative that is coming from functional programming. The alternative in this case is creating a new data structure. So when you were learning programming, you started with values, with integers, strings, that were representing individual values. And at some point in programming, you realized that you wanted to deal with collections of integers, collection of objects, and then you were introduced to the idea of list, of the list data structure. In this case, it's the same. We are going to introduce that new data structure that is going to help us to deal with optional values. I mean, values that can be nil sometimes. And it looks like this. It looks like a box. This box can be full or can be empty. When this box is full, like in the left, we collect sum of A, and if it's not there, we still have the box and we collect none. This is very different to the nil approach that we were talking before, right? When you have a nil, when you have a method that returns a nil, let's say that you have a find customer method that search by email. It will return to you the customer, but what happens if there is no customer with that email? It will return you nil, for example. This will be more consistent. People are familiar with typing, with types. This will be more consistent in the sense that it will always return you a box, this box. So if it can find the customer, it will return you that customer with that email in a box, saying there is some customer. And if it doesn't find it, instead of return just something different, like a nil, is going to return you the same type of box, but empty. So how does this data structure works? The equivalent code for what we were doing before would be like this. So we are doing again this nil, this foo variable equal nil. And then we are calling that maybe constructor. Imagine like when you are creating a list, you're just creating this new instance of the maybe data structure. And then you can, I know this is a bit more complex than the other ones, but you can see there is a pattern there. There is foo wrapped with maybe, there is something bar, something bus, something, and we are appending the OLA there. So it's very similar to the expressions that we had before. It's just that now it's using map. And what is map? What you guys probably have seen it in a list. What do you use map? What do you use it for with a list? With a list, you use map to loop through an array and apply an operation to every element of the array. It's like kind of you are unwrapping those elements from that collection. And with this maybe data structure is the same. With this maybe, once you have the box in there, you need to say, oh, I want to unwrap it, and then do these operations. So in this case, you unwrap the box, then apply the bar operation. Then this will return a box that you unwrap again and apply the bus operation. And do the same and do the append of this string. What's the difference? That now you don't have nils as in the previous cases. If this succeeds, it will return a sum. But if any of those operations didn't have the required data, the whole thing will return none. And why is this good? Why we are trying here to find these nil things? Because when you have nils, it's up to the developer what to do with the nil values. When you have nil, you can choose any of the approaches that we had before if you want. But if you don't want, you don't do anything, and then it will explode in production, and your users will get a weird error. With this approach, with the maybe data structure, you have the advantage that at this stage, you need to unwrap this. You need to unwrap it, and you are forced to do it in a way like this. So you have the maybe value that is maybe zero, maybe not. And if you want to get the value, you need to, for example, give a default like we are doing now. Here we are calling value or nothing, where nothing is the default. So that means when, instead of, if we had a none, we are going to return a default of nothing. Now, this maybe data structure have another method that is really useful that we will see now. Same thing here. We will start with a foo equal nil, and we're going to use flat maps. So what's a flat map? So you can just think about it as the method in arrays. And if you're not familiar with the flat map method in array, I'm going to try to explain it. So what's happening when you call flat map in an array is very similar to a map. It's going to loop through the whole collection, trying to apply the operation to every element. But flat map has a plus, is that is taking in consideration the case when the operation itself results in more arrays. So if the operation itself results in arrays, that plus the original array means that you end up with a nested arrays data structure. And you usually don't want to deal with nested arrays. So what flat map is doing is flattening that at the end. So you had two levels of nested arrays. It's gonna, at the end, it's gonna return you only one normal array. And with that idea, the same happens with our data structure, with our box. So with our box, in this example, we are gonna try to apply the bar operation. If the bar operation itself returns a box, a maybe box, it will mean that we will have two nested boxes. Flat map, what it's going to do is going to reduce those two boxes in just one box. And this becomes very handy because there is a lot of code, especially when you start using these boxes more often. Every method start using boxes, and if you don't use this, you will end up with these nested structures that you don't really want. So yeah, just think about it as another method of the data structure. And the use here is the same at the end. You will end up with a sum or a none, and you need to handle the none case explicitly here. It means here you still have to give the default of nothing. There is another way to unwrap this, and the other way to unwrap this is getting the value or raising exception. That is basically the behavior that we were having before, but in this case it's explicit. So the developer will have to raise the exception by intention. So if you are working with a customer-facing UI, I doubt you're going to do it that you intentionally are going to raise an exception in this case, for example, knowing that it will go to your user. Or, for example, when someone is doing code review, it's easier to spot that the exception is being raised in a place where it shouldn't. So this is the advantage of using these maybes data structures. Why should we care about this? Why it's important? I mean, we already had some ways to deal with this. Is it really worth it? So for me, when I started giving some importance to this, was when I saw that some other languages introduce this maybe data structure into the language. There is a list here that I took from Wikipedia. There's a lot of all those languages implement this maybe type. Most of them are functional, but there is some nice ones that are object oriented. So C++, C#, and Java added this to the language as a built-in feature. Now there is some complexity here. We are adding a functional programming construct in an object-oriented programming language like Java or like Ruby. So what happens here is that people is not going to know how to use it. That happened to me. I didn't know how to use it at the beginning. That causes confusion sometimes. This is a question in Stack Overflow about the use of this maybe type in Java. And the nice thing is that it got replied by one of the architects that was working in the language itself. What he's saying is people will be doing what they want with this. There's no hard rules on this yet. We should try not to overuse this. There is just cases where we want to do this when it's proper optional data, but it's not like we always want to use this for every method. Yeah, I think with more time, I think this blending that is happening between functional programming and object-oriented programming will make it easier for people to see what are the good practices here. But yeah, I think the community is still working that, not just in the Ruby community, I think in most of the programming language communities. Finally, I would like to show you an example how I started doing this in one of the projects at EA. But first, I need to explain you how it works in the library that I was using. I was using a library called Dry Monads that has this maybe box, and I actually did a trick here. I have been talking about map and flat map all the time because I just find it easier because it's the same as the one in lists, in a Ruby list. That's actually as well the same names that is using Scala. But in the Ruby library for this is it's influenced by Haskell, the programming language Haskell. So they are using actually these names that I find confusing. So instead of map, they use fmap, and instead of flat map, they just bind. And they have even a tier name for map, maybe that have a slightly different behavior. So with that change in terminology, this is how it will look like in one of our projects. So this is some code that is trying to detect car type mismatch, and that first class is returning a maybe box, and then it's doing an fmap. So a map is unwrapping it to create a support ticket. Now we're going to see how that detect car type mismatch is implemented to return that box. This will be the class, and the main code that you need to have a look to is this. So it's just basically saying if there is a car type mismatch, we're using this for like frauds, trying to identify frauds in our website. So if there is a car type mismatch, in this case, it's returning a sum, the box full, with a message that we will create the ticket with. But if there is not a type mismatch, we will just return a none. So instead of returning a nil, like we will usually do, we return the empty box, and that forces us to handle it here properly. So that's the fmap. That's why the fmap is there. Yeah, that's the example. We have been talking today about the maybe data structure of the maybe box, but there is some other similar data structures like this. This is the one that we talked about some minutes ago, and there is some other boxes that looks quite the same. So we have this try that structure that converts a piece of code that returns an exception in boxes. So in the successful case, you get this value box in green, and before you were raising an exception, now you're returning an error box. Quite similar to the idea of maybe, and same with this one, the result box, the result data structure. So this is when you have this when you have different paths for your code, one usually for success and one for failure, you want to put that in your business logic. You don't want to raise exceptions, anything like that. So quite similar. It's like only the names are changing, if you can realize. Yeah, it's the same idea. So you probably already realize you can generalize from this. So the generalization of all this data structure is called monads, and that's probably what you have heard before from the functional programming guys. This is the name of the abstraction, and if you want to look for it in as the library implemented in Ruby, it's called dry monads. I definitely encourage you to have a look to it and study it. I think it's really cool, and I think it's going to be used probably when I think it's already been used in the community, but I think it probably would increase the use in the future. And that's it for me. There is my email if you have any question. I don't know if there is any questions right now.
Thank you, Carlos. That was super interesting. I didn't realize that the optionals I'd seen in Java were also things that came up in Ruby. If anybody would like to ask a question, go ahead. The floor is open.
How extensively have you used this yourself?
Good question. So I started using that in my previous company. If anyone is familiar with a company called Belroy, they're in the fashion industry, and a lot of people there were fascinated by Haskell. So we started using this library extensively there. Then I moved to REA, and they were using a similar library that was non-maintained anymore. So in one of our hack days, I refactored that code base and I replaced it with this monads library. So yeah, we are using it now in that project. That's the use that I have done. I am really enjoying it, by the way.
I wonder how this compares to other approaches to avoid unexpected nils, like sorbet. I don't know whether you would use both of them together or whether one of them solves it better than the other. I don't know.
Yeah, that's a good question. So just for people that haven't heard about sorbet, sorbet is a static type system for Ruby. So you basically are trying to transform Ruby in something like Java. Yeah, and that's a very good question. So this is interesting because as I was saying, one of the hack projects, I refactored this code base to use monads. And in the next hack day that we had at REA, I refactored the same code base to use sorbet on top as well. So we are using both there. I have to say that they don't play that nicely at the moment. Yeah, and I think it's a different concept. With sorbet, you still can have nillable types. So it's like in Java. In Java you have static typing, and you can still have nils. So
But
if you add
sorbet will force you to handle the nil case, right? You can't call a method on something that is potentially nil. Is that?
I don't think so, because I think you can return a nillable type of a class. So that will mean that you could return nil or the class. But yeah, I think it's a different concept. Well, what I have seen from sorbet, there is not a lot of information about sorbet. It's quite new, but what I have seen from the Slack group that they have is that in what's the name? In Stripe, well, they created this sorbet thing. The way that they are using it is that they have their own implementations of data structures that are basically like these monads, but simpler. and they are still using it, but that's not public. That's just internally in their projects. So yeah, you can implement it nicely with Sorbet. There is some implementations you can if you Google for Sorbet result. I think there is an implementation of the result monad that is based on the Rust API, but implemented with Sorbet.
Oh, cool.
That was very interesting.
Yeah, thanks.
Carlos, we have a question in the chat as well. And the question is, in the maybe.flatmap calls, should the function call be wrapping the result in an instance of maybe rather than just the result of the underlying function?
Let's go back to that slide, if I can find it. You're talking about this one, right? And can I see that question in the chat? Okay, it's saying in the maybe flat map call, should the functional call be wrapping the result in an instance of maybe rather than just the result, of the underlying function result?
Yeah, so the difference between map and flat map is that from what I understand from your explanation is that map you use when the method bar doesn't return a box, right?
Yep. Yep.
And you use flat map when bar does return a box.
Yep.
Because if you just use map with a bar that returned a box, you'd end up with a maybe inside a maybe.
Yep. Yep. That's it. Yeah, that's right. So what was the question there?
I think that was the question. That bar in that second case is a different definition. That.
Oh yeah. Sorry. Yeah.
Puts it in a box.
That will be a different definition. Yeah. It in this case will be when bar is returning another box. Yeah. Sorry, I get it now. Yeah. Yeah. So as I was mentioning before, I think this is tricky to understand. I think it was tricky for me to understand at the beginning when to use map or when to use flat map. I think it's easier to see when you're working with a static type language like Scala. But even with the Scala, I remember when someone was teaching me Scala in REA, they were like, what I do is I usually try with one of them, and if it doesn't work, if the compiler is not happy, I just try with the other one. That was quite interesting, but yeah, I prefer to remember how to choose between both as you mentioned before. Like if the method doesn't return a box, then I just use map, and if it's returning itself a box, then I use the flat map.
I think that's called compiler-driven development.
Yeah.
Any other questions for Carlos?
Carlos, thanks for the talk. I applaud your efforts to get people to use more functional programming, whether in Ruby or not. But I was curious in the stuff before you introduced the maybe type, you had sort of some railway oriented programming style code. And that would normally be where in Ruby, you'd probably introduce something like the null object pattern. I'm curious whether you've used that in Angular and how you can compare that usage with, say, using the maybe monad.
Yeah, that's an interesting question. So for people that is not familiar with the null object pattern, The null object pattern basically means that you will create like a dummy object that every time that you need to return, instead of nil, you will return that dummy object. Yeah, I think that that's a valid case. Actually, I used to have in my slides not a null object pattern, but something similar. It was called I think it was called like black hole object or something like that. If anyone is familiar with what's this guy? The guy from Ruby Tapas, Abdi Grim. So he has a book that is called Confident Ruby. And he talks about this as well, without talking about functional programming. So he basically has this implementation of the null pattern with more specific behavior that looks more like a maybe monad. Yeah, that's the one called black hole, but it returns. It still returns nil, so it doesn't have this consistency on the type that we were talking about before, like always returning the box. And the other problem is it was not very idiomatic. That was the other problem that he was mentioning, at least in his implementation. Yeah, the other benefit I see with monads instead of using this null object pattern is that with the null object pattern you have to implement it every time, right? For every object that you want to do. While with these monads, it's like you have like a more general abstracted pattern that you can use everywhere. It abstracts. There is more behavior that I haven't shown to you guys today, but there's more things that are common to all the monads, and it's abstracted. And then you can just reuse it instead of implementing it all the time, every time. I think that's the other advantage, having a kind of a canonical implementation of this that everyone can refer to. Does that respond to your question?
Yeah, I think there's sort of just different takes on what you actually prefer to end up within your code and what you're more comfortable with. Yeah.
Yeah. Sure.
Cool. Thank you.
Any other question?
I've got, it's not exactly a question, but it's more of a comment, I guess. Can you go back to the slide that has the safe navigation, the ampersand dot syntax? Yeah, at the bottom there. So I really like this syntax a lot, but some people in our team have noticed that it works differently to how it does in JavaScript with the question mark dot or the dot, question mark dot, because in JavaScript, if say here foo was nil, you would still need to have the ampersand dot on the baz call and the dot plus call, because it doesn't kind of break from the expression like it does in JavaScript. You would only need it on the first dot in JavaScript, if that makes sense. If the other functions always return a non-null value. Has anyone had experience with that difference between how JavaScript and Ruby handles this?
It can totally be unexpected. So you need to be well versed in how it works before you add that to anything, because it doesn't break off. It's not the same as that line above with the double ampersand at each point, that if something is falsy, that it stops. It carries on and it tries to do the thing on the nil. So yeah, totally something to keep in mind.
Yeah, I don't use much JavaScript, but yeah, something similar is what happened with these two versions. Like the basic behavior is the same, but there is some edge cases where they both don't behave the same.
Yeah, I've found that if you introduce an ampersand dot, you basically have to introduce it for every other call in that expression. Otherwise, you'll still have a nil problem if it fails.
Nice. Was that only JavaScript or TypeScript?
No,
don't work
that's
with
in Ruby.
Oh, in Ruby, sorry.
Yeah, in JavaScript it works a little bit better, I would say, but it's still a bit strange behavior.
Cool. Thanks for sharing that. Any other questions? Cool. Then I think that's it. Thank you so much, guys. Hope you enjoyed it.
Thank you very much. I definitely did. Yes, all of our remote clapping options, however we like to do it. Love the full screen of clap emojis, all those good things. That's what we want to see.
And thanks, Celia, for inviting me.